So we have this system of equations, yes? How did we try to solve it yesterday? Substitution, right? We tried to solve for a variable, substitute it back into 2 different times to get an equation with 2 variables, and then we know how to do an equation with 2 variables, right? It was long and kind of drawn out, wasn't it? Okay? So today I'm going to teach you how to do elimination with 3 variables. Okay? We start off the same way as we do elimination with 2 variables. We want to try to combine 2 of these equations to try to eliminate a variable. Okay? So which variable do you think we should try to eliminate first? Is there a better choice? So let's talk about that real quick. Let's talk about how to make that first choice. Is that okay? Okay. So if we look at just the x's, notice top and bottom, we already have opposite numbers, don't we? So if we added top and bottom together right away, x would eliminate, wouldn't it? That's awesome. But you know, we'll probably have to eliminate again. So I have a 3x. That's a pretty low number, right? So if I multiplied the bottom one by 3 and added it to the middle, wouldn't that be pretty easy? So x is probably a good choice. Okay, let's look at y's. I've got a y by itself. That always helps. Then I've got a 2y and a 5y. Okay, so nothing is going to eliminate right off the bat if I just added them together, right? So I'd have to do some work. So I'd have to multiply the top by -2, probably, and combine it with the middle. And then I'll probably have to do it again, right? So multiply the top by -5 and combine it with the bottom. Still, that's not difficult, is it? Okay? So, but between x's and y's, which one do you think would be a better choice? Probably x's, because we have one that would eliminate right away, right? Now let's look at z's. Notice z's are good because I have one that would eliminate right away. And then I have another one, the second one, it's not that big of a number, right? So I could multiply the whole top by 4 and combine it with the middle, and that would eliminate the z's, wouldn't it? Okay? So in your opinion, because that's what it is right now, which one is the best one to eliminate? You think x. Does anybody else think any different? Okay? For the record, in my opinion, x's would be the easiest. Because x's and z's are pretty close. It's just between this number right here, right? And 3 is smaller. Does that make sense? So, would you like to try to eliminate the x's first? If we're going to try to eliminate the x's first, what should we do, you think? First things first, we should combine top and bottom, right? Because we already talked about that a minute ago, that x's would go away, right, if we did that. Okay? So if we combine top and bottom, I'm going to go ahead and write them over here to the side again so I have it written down. X plus y minus z equals 4. And then the bottom one is -x plus 5y plus z equals 8. If I straight combine them, ooh, look what happens. That's 0, isn't it? This is 6y. Look at that. Equals 12. I just eliminated 2 variables, didn't I? If I divide both sides by 6, I get y equals 2. Well, that's all fine and good, but I still need my other 2 variables, don't I? Okay, so I know y, and that's great, but I still have some work to do to get the other 2 variables, right? What should I do next? So I'm going to plug this back into an original equation. Is that what I want you to do? Is that what you want to do? Yes. Okay, that's one choice for the record. Okay, remember how we talked about the fact that when we solved absolute value equations, there were literally 5 steps that we did on every single problem, and we did all of them the same way every time, right? I can't give you steps here. We got step 1. Step 1 we can do every time. Don't panic, right? But there's like 14 things I can do right now, like for real. I don't know if it's exactly 14, but it's up there, okay? Because here's what I could do. I could choose to ignore this and start over and come back to the original. I just tried to eliminate x. I ended up eliminating both. But what if now I tried to eliminate z's? And maybe try to get rid of these two? What if I try to eliminate y's over here? You see what I'm saying? I have options. I could come over here and try to eliminate x again. Because if I try to eliminate x again, that would give me an equation with y and z. And I already know y, so I could plug that in. Or I could take y and plug. Do you see how many options there are? Okay, so we have to go back to step 1. Especially when we're feeling overwhelmed with all of the options that are possible. Okay, because here's the best part. No matter which option you choose, as long as you're doing the mathematics correct, you're going to get the right answer. Okay? As long as your arithmetic is correct, as long as you're making sure your signs are correct, there's 14 right ways to do the next step. Does that make sense? Okay. So, step 1, don't panic. If you ever get panicked, go back to step 1. It's still don't panic. Okay? So, we have y equals 2. What would you like to do now, or would you like guidance? Guidance? Okay. So I think probably what I would do now, if I were doing this problem.
Teachers, please find this interruption. At this time, please release all freshmen to the H-Pack. Thank you.
So if I were doing this problem, and I am, right, I would probably go back over here. I would ignore this for a second. I would go back over here and I would eliminate x again. That's what I did in the beginning to get this, but I want to go back over here and eliminate x again. So to do that, I'm going to rewrite my middle equation. 3x plus 2y plus 4z equals 17. And then I'm going to multiply my whole last equation by 3. I know I wrote 2, I'm sorry. I'm going to multiply my whole last equation by 3. And I'm going to write it underneath that. Are you okay with that? So negative 3x plus 15y plus 3z equals 24. Now what's going to happen if I add these two together right now? Well, x's are going to go away, aren't they? What's going to happen right here? 17y. What's going to happen right here? 7z equals what? 41. But then I think to myself, I already know y. Why couldn't I bring y, this y right here, and put it right there? Couldn't I do that? So 17 times 2 plus 7z equals 41. What is 17 times 2? 34 plus 7z equals 41. To solve for z, first I would subtract 34 from both sides. Good job. 7z equals 7. When I go to divide both sides by 7, z equals 1. I know y and I know z. What am I missing? So where do we go to try to figure out x? That's where I would go. Okay? I know both y and z. There's no other like shortcuts I can go to. I got to go back to the original equation. And just like she said, I would choose the first one. Why would I choose the first one? X is by itself. All these are small. Right? Because x is what I'm trying to solve for. X is already solved for in that equation, right? Is this a bad choice? No, but these numbers are a little bit bigger. Is this a bad choice? No, but this is negative. You know how I feel about negatives, right? So I would choose the first one. But again, both of these are also okay choices. I just feel like this one is better. Okay? So I'm going to take it down here. X plus 2 minus 1 equals 4. Because I'm just plugging in what I know, right? So x plus 1 equals 4. So x equals 3. X, y, z. What is my answer? 3, 2, 1, blast off. Okay? Any questions? Now, so this is my answer, right? This is the one I'm going to enter in the computer. This is one I'm going to put a nice solid box around on a test so that your teacher can find it easily, right? Okay? What does this mean again? First of all, what's it called? Ordered triple, right? Good. An ordered triple, okay? What does it actually mean? Do you remember? Can I remind you? Isn't this a point in three-dimensional space? Can you graph that? If you're careful, you can. Because you've got your x-axis and your y-axis and your z-axis. Can you see it coming out of the paper? Right? And you can go over 3 and up 2 and out 1. It's a point in three-dimensional space where 3 planes intersect. Okay? Do you see why we don't graph it very often? It's not easy, right? Because really, it's over 3, up 2, and out 1. So it's really like floating in space above the paper right here, right? Can't graph that. But if we can try to see that the z-axis is actually coming through the paper, you can see that I went over 3, up 2, and out 1. Yeah? Okay? Any questions about that? So are we always going to get lucky and have 2 of the variables eliminate right in the first step? No, so maybe we should do one where we didn't get lucky. Is that okay? Let's do one like that. We have x plus 4y minus 6z equals negative 1. We have 2x minus y plus 2z equals negative 7. And we have negative x plus 2y minus 4z equals 5. Can we take a quick commercial break and go back to this one real fast? It's not really a commercial, it's just like a revamp of the problem. What did we not do when we got all the way done? We didn't check it, right? Should we? 3 plus 2. I'm sorry, does anyone know what 3 plus 2 is? 5. Okay, 5 minus 1? 4. We're good, right? Okay, 9 plus 4. 13 plus 4. 17. That one's good too, right? Right, negative 3 plus 10. 7 plus 1. Oh, perfect. Right? Is it really that important to do that step? Yes. Yes. Okay. All right, back to this problem. Let's talk through the variables and see which one would be the best to choose. Okay? Look at the x's. If we tried to eliminate x's right away, I could add these 2 and x's would be gone, right? And then I would probably have to do it again. So at least I have these 2 where they're already opposite signs. So I just have to multiply this equation by what? 2, right? To get to eliminate with this. So would that be pretty relatively simple? Yes. Okay, let's look at y's. So I don't have already exact opposites like I did here, but what I do have is opposite signs. And the opposite sign of these 2 is the one that's the y. So I just have to multiply this by 2 and combine it with this one. That's pretty easy, right? I'd have to do it again probably. So again, I have an opposite sign of 4. So I could multiply this one by 4 and combine it with the top. Or I could multiply this bottom one by negative 2 and combine it with the top, right? Also not difficult, correct? Look at the z's. Again, I'm lucky because I have opposite signs. So I could multiply this one by what? 2 and add it with the bottom, and that would eliminate. I could multiply this one by what? 3 and add it with the top and eliminate. Of those possibilities, which one is, in your opinion, is the easiest? X. I agree with that. Okay. Again, it's just opinion though, right? Okay. But is it okay if we go with X? So if we're going with X, what are we going to do first? Combine top and bottom. Okay. So I'm going to write the top right here. X, 4y, negative 6, negative 1. And I'm going to write the bottom right here. Negative x, 2y, negative 4, 5. And I'm going to combine them. What do I get when I combine them? 6y minus 10z equals 4. Excellent. Okay? Now, what do I have? I have one equation with y and z. What do I need? If I have one equation with y and z, I need another equation with y and z. Okay? Now, some people's first reaction is to try to solve for one of these variables because they like substitution, and if you do, that's great. I'm actually not a fan of it. I think elimination is easier, but that's my opinion. If you like substitution, go for it. Okay? But if I have one equation with y and z, no matter if I'm doing substitution or elimination, I need another equation with y and z. Okay? So I need to go back to the beginning. I ignore this for a second. Go back to the beginning and eliminate x again. Okay? So I chose a variable to eliminate. Only one eliminated. So I go back to the beginning and eliminate that variable again. How would you like to do that? You would like to multiply the bottom one by 2? Okay, I'm okay with that. If I multiply the bottom one by 2, I get negative 2x plus 4y minus 8z equals 10. Do you agree with me? Okay, I'm going to go ahead and rewrite this middle one right underneath it so I have them close. That's not necessary. I'm just doing it to try to help you guys out. Okay? And now I'm going to combine these two. That's 0. That's 3y. That's negative 6z. And that's 3. Yes? Now I have two equations with y and z. And now I kind of start again. Which variable would you like to eliminate? The y or the z? The y would be easier, wouldn't it? What do I need to multiply which equation by to get the y's to eliminate? By negative 3? Okay, good. If I multiply this bottom equation by negative 3, I'm going to write it right over here. I get, excuse me. Thank you. I heard negative 3 and didn't even use my brain to think. Okay? So negative 6y minus 12, plus 12z equals negative 6. Yes? Are these two close enough so that I can just add them like this? Okay, so 6y and negative 6y, that's 0. Negative 10z and 12z, 2z, and 4 and negative 6. Haha. Z equals negative 1. What do I do with that? Where would you like to plug it in? Where would be the smartest place to plug it in? Like up here? Oh, we could use this bottom one, couldn't we? Isn't this already just y and z? And if I plug in z, what am I going to find? Y. So I'm going to take this z and put it right there. Okay? So I have 3y minus 6 times negative 1 equals 3. Well, negative 6 times negative 1 is plus 6, correct? So if I subtract 6 from both sides, I get 3y equals negative 3. Dividing both sides by 3 gives me y. So I'm going to divide both sides by 3. So y equals negative 1. So I know z and I know y. Where do I go? If I know z and I know y, only place I can find x is back at the beginning. Is there a better equation back at the beginning for me to choose? Probably the first one, because x is already by itself in the first equation. So if I rewrite the first equation but substitute in what I know for y and z, I get x plus 4 times negative 1 minus 6 times negative 1 equals negative 1, which gives me x minus 4 plus 6 equals negative 1. So x plus 2 equals negative 1. And subtracting 2 on both sides gives me x equals negative 3. Those are my three variables. How do we write our answer? As an ordered triple. In what order? X, Y, Z. Alphabetical. Okay, so that right there is my solution. Now, real quick, let's talk through it again, how we got here. Actually, we should check it first, right? So negative 3 minus 4 is negative 1. Excuse me. Negative 3 minus 4 is positive 1. Wait, what am I saying? Negative 3 minus 4 is negative 7. Negative 7 plus 6 is negative 1. Sorry. Put it into the second point. Negative 6 plus 1 is negative 5. Negative 5 minus 2 is negative 7. Okay? 3 minus 2 is 1. 1 plus 4 is 5. Okay? So I know for sure the solution is correct. Now, let's talk through what we just did. Okay? We started from our original problem. We looked at all of our variables and decided of all three variables, we choose to eliminate x first. So we used top and bottom to eliminate x, which gave us one equation with y and z. If I have one equation with y and z, what do I need? I need another equation with y and z. So I went back to the beginning. I ignored this one for a second and went back to the beginning. And from the beginning, I eliminated x again. Okay, so in this particular case, I use the middle and the bottom, multiplying the bottom equation by 2 and combining those to eliminate x again. I have now two equations, both with y and z, and I use those to eliminate, in this case, y, but I use those to eliminate a variable to solve for a variable. I take that and plug it back into one of these two equations I just used to solve for another variable. I take those two variables that I know and go back to the beginning to find the third variable.